China is building things right now that the rest of the world has not even started planning. We are talking about a train that moves faster than a plane takes off, a radio telescope so large it covers 30 football fields and is listening for life beyond our solar system. A canal carved through mountains that took 100 years for anyone on Earth to attempt again, and a dam that will produce more electricity than an entire country consumes in a year. All of this is happening at the same time, right now. While most countries are still debating whether a project is worth funding, China is already done with it and moving on to the next one. That gap between what China is doing and what everyone else is doing is what this video is about. We are going to walk through 10 construction projects that prove China is operating in a completely different league. Some of these will make you question what you thought was possible. And by the time we get to the last one, you will understand exactly why engineers around the world are paying very close attention to what is happening in China right now. Let's get into it. Yarlung Tangpo Mega Dam, project of the century. There is a river in Tibet called the Yarlung Tsangpo. It starts high in the Himalayas and drops nearly 2,000 meters in elevation over just 50 kilometers. That kind of drop is extremely rare on Earth. Most rivers take hundreds of kilometers to drop that much. This one does it in the length of a city. For decades, engineers looked at that drop and knew there was an opportunity sitting there. A massive, almost unreal amount of energy waiting to be captured. The problem was that building anything there seemed almost impossible. The terrain is extreme, the altitude is punishing, the river is powerful, and the scale of what would be needed was bigger than anything ever attempted. China decided to attempt it anyway. In July 2025, construction officially began on the Yarlung Tangpo Mega Dam, also called the Maydog Hydropower Station. The total cost is estimated at $170 billion, making it the most expensive infrastructure project in human history. But the number that really puts this in perspective is the energy output. When complete, this dam will generate 300 terawatt-hours of electricity every single year. To understand what that means, the Three Gorges Dam, which was itself the largest dam ever built when it opened and held that record for years, produces about 88 terawatt-hours annually. The Yarlung Tangpo Dam will produce nearly 3.5 times that amount. It will generate more electricity per year than the entire United Kingdom consumes. And it is not just one structure. It is a series of 5 cascade dams working together, all exploiting that incredible 2,000-meter drop to squeeze every possible unit of energy out of the river. Premier Li Qiang called it the project of the century. That is not marketing language. When you look at the numbers, it is an accurate description. The electricity this dam produces will power hundreds of millions of people with clean energy. No coal, no gas, no emissions. Just water falling exactly where nature placed it, captured by engineering that no other country on Earth has ever come close to pulling off. Now, if a dam of that scale has you thinking China only goes big when it comes to energy, the next project will show you that they apply the exact same thinking to places where most engineers would not even try to build a bridge. Huajiang Canyon Bridge, world's highest bridge. In the Guizhou province of southern China, there is a canyon called the Huajiang Grand Canyon. Standing at the edge of it and looking down, the river at the bottom looks like a thin ribbon. That is how deep it is. The drop from the rim of that canyon to the water below is 625 meters. That is taller than the Empire State Building, nearly twice the height of the Eiffel Tower, and China built a bridge across it. The Huajiang Canyon Bridge is officially the highest bridge in the world. Its main span stretches 1,420 meters across the gap. Workers use drones and China's Beidou satellite navigation system to position cables with accuracy that traditional methods could never achieve at that height and scale. The construction took just 3 years. A bridge across a canyon that is 625 meters deep. with a span of over 1,400 meters, finished in 3 years. Before this bridge existed, traveling from one side of the canyon to the other took around 4 hours by road. You had to drive all the way down, cross at the bottom, and drive all the way back up. That 4-hour journey is now 4 minutes. 4 hours to 4 minutes. That is not an improvement. That is a complete transformation of how people in that region live and move. The Huajiang Canyon Bridge is open to the public now, and it has quickly become one of the most visited engineering sites in China. People come not just to cross it, but to stand on it and look down at where they used to have to drive. And if you think 600 meters above a river sounds extreme, the next project took on something even more unpredictable: the open ocean. Hong Kong-Zhuhai-Macau Bridge, world's longest sea crossing. Bridges over water are common. Short ones, medium ones, even fairly long ones exist all over the world. But the Hong Kong-Zhuhai-Macau Bridge is not a bridge over calm, shallow water. It crosses the Pearl River Delta, one of the most active shipping channels in Asia, where massive cargo ships move through at all hours. Building a bridge that cars could drive across without interrupting that shipping traffic required something that no bridge had ever done before. Part of this crossing goes underground. Engineers built an undersea tunnel that dips below the surface of the sea so ships can pass over it without any obstruction. To create entry and exit points for that tunnel in the middle of the ocean, they built 2 artificial islands from scratch, in open water, before construction of anything else could begin. The total length of the crossing is 55.5 kilometers. That makes it the longest sea crossing bridge and tunnel system ever built. The bridge sections alone are long enough that you can see the curvature of the Earth while driving across. It was engineered to withstand a Category 16 typhoon, a magnitude 8 earthquake, and a direct strike from a 300,000-ton vessel. Those are not small margins. That is a structure built to survive almost anything the ocean and the sky can throw at it, and then keep standing for 120 years. Travel time between Hong Kong and Zhuhai dropped from over 3 hours by road to about 40 minutes. For 2 cities separated by open sea, that kind of connection changes everything about trade, tourism, and everyday life. Building a road across open ocean is already remarkable. But the next project takes on something even more extreme. Not ocean, not canyon, a mountain range that is actively trying to stop anyone from building anything. Sichuan-Tibet Railway, the impossible railway. There are places on Earth where nature makes it very clear that humans are not supposed to build things. The stretch of terrain between Sichuan province and Lhasa in Tibet is one of those places. It sits above 3,000 meters of altitude for most of the route. Avalanches happen, glaciers shift, landslides are common. The ground shakes because 14 active fault lines run directly through the path. And underground, when you drill into the rock to build tunnels, the temperature inside can reach 89 degrees Celsius. That is nearly boiling water. Drilling through it is not just difficult, it is dangerous in ways that normal tunnel construction never has to account for. China is building a railway through all of it. The Sichuan-Tibet Railway covers nearly 2,000 kilometers. Along just one section, engineers had to build 47 tunnels and 121 bridges. 90% of the route sits above 3,000 meters. The workers there cannot always breathe normally. Specialized machines had to be designed from scratch just to function in the cold and the thin air. No country has attempted a railway project under these conditions before. Not because they did not think of it, because the engineering community considered it technically impossible for decades. China looked at that assessment and started building anyway. When this railway is complete, one of the most remote regions on the planet will be connected to the rest of China in a fraction of the time it takes today. A journey that currently takes days will take hours. The Sichuan-Tibet Railway is a project that keeps going despite every reason to stop. And as impressive as it is, it turns out that building a railway through the most difficult terrain on Earth is not even the most extreme thing China has done with a dam. That title belongs to what comes next. Shuangjiangkou Dam, world's tallest dam. Picture a building 100 stories tall, not a wide building with many floors spread across a large area. A tower, straight up, 100 floors reaching into the sky. Now picture that entire structure being a dam, holding back a river that would flood everything downstream if it ever gave way. That is the Shuangjiangkou Dam in Sichuan province. It stands 315 meters high, making it the tallest dam ever built anywhere in the world. The previous record holder was the Nurek Dam in Tajikistan at 300 meters. China did not just match it, China beat it and built in one of the most seismically active regions in the country. Sichuan sits on fault lines. Earthquakes here are not hypothetical risks. They happen. The Great Sichuan Earthquake of 2008 measured 8.0 on the scale and killed nearly 70,000 people. Building a 315-meter dam in this region meant designing for forces that could try to bring it down at any moment. Engineers used a rock-fill design, packing the structure with carefully selected stone and earth in layers calculated to absorb seismic energy without cracking. The reservoir began filling in May of 2025, and the first power units are now coming online. When fully running, the dam will generate 3 gigawatts of clean electricity, enough to power millions of homes. What makes this even more striking is that China did not find a safe, convenient spot for this record. It found the best place for the river and built there, even knowing the ground would shake. That kind of commitment to doing something right, rather than doing it easily, shows up again in the next project, which is less about function and more about what happens when you let extraordinary design lead the way. Beijing Daxing International Airport, the starfish from space. When the design for Beijing's new airport was first published, many people assumed it was a concept image for a movie. The shape looked like a golden starfish, with 6 sweeping arms curving outward from a central core. The roof flowed in smooth curves without sharp edges. It looked organic, almost alive, like something that had grown rather than been built. Zaha Hadid architects designed it. China built it in 5 years. Beijing Daxing International Airport opened in 2019. The terminal building covers 700,000 square meters, the equivalent of about 97 football pitches under a single roof. It is the largest single airport terminal building ever constructed anywhere in the world. But what sets it apart is not just the size, it is the logic behind the shape. Because of the starfish design, every gate is within 600 meters of the central hub. No matter where your flight departs from, you are never more than a short walk from the center. Compare that to older airports, where reaching your gate requires a 20-minute hike through identical corridors, and the design starts to feel like a genuine act of kindness toward travelers. The airport handles up to 100 million passengers per year and cost about $11.5 billion to build. It won design awards around the world, but more important than the awards is what it represents. A country that does not separate beauty from function. A country that believes infrastructure can be both useful and extraordinary at the same time. Daxing proves that China builds for the future, not just for the present. And nowhere is that philosophy more visible than in the next project, which is not a single structure but an entire city designed from scratch. Xiong'an New Area, China's city of tomorrow. Most cities were not planned, they grew. Somebody built a house, then a neighbor built one next to it, then a road appeared, then a market, and over generations a city formed. That is why most cities today are full of problems that nobody designed into them on purpose. Traffic that moves slowly because the roads were built before cars existed. Power lines strung above streets because nobody thought to bury them underground. Neighborhoods that have everything and neighborhoods that have nothing because growth was never coordinated. Xiong'an starts with none of those problems because Xiong'an started with nothing. About 100 kilometers south of Beijing, on a flat stretch of land in Hebei province, China is building a city from a blank page. Every road, every pipe, every power line, every park, every transit stop was designed together as one complete system before a single piece of ground was broken. Artificial intelligence modeled how the city would function with 5 million people living in it and used that information to guide every decision. There are no power lines above ground. All utilities run underground through a network of shared tunnels that can be accessed for maintenance without ever digging up a street. The transit system is coordinated by software that adjusts in real time based on where people are going. Any public facility, a school, a hospital, a park, a train station, is within 15 minutes of any home in the city. Forest coverage has been raised from 11% to 35% across the entire area. Over 100,000 university students have already moved there. More than 300 companies have relocated their operations. The city is not finished, but it is already being lived in. And what people find there is a version of city life that feels genuinely different from anywhere else on Earth. Zhong'an is the answer to the question that urban planners have been asking for decades. What would a city look like if you built it knowing everything we know now? And while Zhong'an looks inward at how people live, the next project looks outward, farther than anything humans have ever managed to see or hear before. Fast Radio Telescope, China Sky Eye. In a natural bowl among the mountains of Guizhou Province, China built the largest ear ever pointed at the universe. The 500-meter aperture spherical telescope, known as FAST or China Sky Eye, is exactly what the name says. 500 meters across. That is 30 football fields laid side by side. It sits in a valley shaped by nature over millions of years, a bowl that makes the perfect cradle for a structure of this size. Its nearest competitor was the Arecibo Observatory in Puerto Rico, which was 300 meters across. Arecibo collapsed in 2020. There is now no other telescope on Earth in the same category as FAST. What does it actually do? It listens. It picks up radio signals from space, energy waves traveling across unimaginable distances from objects so far away that the signals left before complex life existed on Earth. Since FAST turned on, it has discovered over 1,000 pulsars. Pulsars are rotating stars that send out energy pulses like a lighthouse in space. And finding them helps scientists understand the structure of the universe at a level that was simply out of reach before. But there is another reason FAST captures people's imagination. It is also scanning for signals from other civilizations. If intelligent life exists somewhere in the universe and is sending out any kind of detectable signal, FAST is the most powerful tool humanity has ever built to hear it. One telescope in a mountain valley built to listen to the entire universe. If that is not enough to make you pause for a second, the next project will bring things back to Earth, specifically to a rail network moving faster than most planes take off. CR-450, Fuxing, high-speed train, the ground rocket. A Boeing 737 airplane lifts off the runway at roughly 280 kilometers per hour. At that speed, the wheels leave the ground and the plane begins to fly. It is one of the most powerful moments in everyday travel, the feeling of a large machine crossing the line between road and air. China's CR-450 train hit 453 kilometers per hour during test runs in 2025. On the ground, on rails. That speed is not just a number to be proud of. It represents a completely different idea about what land travel can be. The CR-450 is designed for an operating speed of 400 kilometers per hour on China's existing high-speed rail network. When it enters full service, a trip from Beijing to Shanghai, over 1,000 kilometers, will take about 2.5 hours. The same journey by car takes more than 10 hours. And the network this train runs on is already the largest on Earth. 48,000 kilometers of high-speed rail, more than all other countries combined. China's plan is to expand that to 70,000 kilometers by 2035. That is enough track to wrap around the entire planet nearly twice. While other countries debate whether high-speed rail is worth the investment, China is already thinking about the next generation of what high-speed rail can become. The CR 450 is not the end point of that thinking. It is the current step. Speed on land is impressive, but the last project on this list is not about speed. It is about something far more fundamental, something that could change how the entire world handles energy for the next century. Pinglu Canal, China's first new canal in 1,000 years. The last project on this list does not look as dramatic as a dam standing 300 meters tall or a bridge hanging over a canyon. It is a canal, a long, wide channel of water cut through the ground. And yet, when you understand what it means and why it exists, it might be the most telling project of everything we have covered today. The Pinglu Canal is 134 kilometers long. It runs through the Guangxi region of southern China, and it was built by cutting directly through mountains. Construction began in 2023. It is expected to open in 2026. 3 years from start to finish for a canal carved through mountains. The last time a canal of this scale was built anywhere in the world was over 100 years ago. The Panama Canal was completed in 1914. The Suez Canal was completed in 1869. Since then, no country has built a major new canal of this scope, until now. Before Pinglu existed, the Guangxi region had no direct access to the sea. Everything produced there, goods, materials, exports, had to travel hundreds of extra kilometers to reach a port. That added time and cost to every shipment, every transaction, every business operating in the region. The Pinglu Canal changes that completely. It cuts 560 kilometers off existing shipping routes and gives an entire landlocked province its own path to the ocean. The economic impact of that is hard to overstate. Industries that were too expensive to operate in Guangxi because of the distance to ports suddenly become viable. Goods move faster, costs drop, trade increases. An entire region's economic potential gets unlocked by one canal. But here is the part that sits with you when you think about the full picture of everything in this video. The Pinglu Canal is not even considered one of China's flashiest or most publicized projects. It is not the one getting headlines around the world every week. It is just something that needed to be built, so China built it, on time, at a scale nobody else would attempt, without making much noise about it. That quiet, consistent ability to execute on the tallest dam, the longest sea crossing, the highest bridge, the fastest train, the biggest telescope, an entirely new city, and a canal through mountains, all happening at the same time, is what separates China from everyone else right now. This is not one big project. This is a pattern, and once you see the pattern, you cannot unsee it. 10 projects, one country, and a gap between what China is building and what the rest of the world is building that is getting wider every year. If this video gave you something to think about, hit the like button and subscribe so you don't miss what we cover next. Turn on notifications because some of the stories coming up on this channel are just as hard to believe as everything you just watched. And I want to know what you think. Out of everything we covered today, which one project surprised you the most? Drop it in the comments below.